Hello, how's it going, guys? We're going to do section 10.1 of the book, Sequences as Functions. Let's get our notebooks out and let's jot down today's date. Let's jot down the title, 10.1 notes. And yeah, the title of the book says Sequences and Functions, but we're going to actually write down arithmetic versus geometric in addition to the title, because that's what we're doing today. The goal is to be able to look at a list of numbers and determine whether it's arithmetic or geometric. And we'll get to all of that in a little while. Let's begin by reading the book here. It says a sequence is a set of numbers. It's just a list of numbers. It's in a particular order or pattern. Okay. Each number is a sequence. Each number in a sequence is called a term. A sequence may be finite or infinite. Right. A finite sequence containing a limited number of terms, such as -2, 0, 2, 4, 6. Or infinite sequence that continues without end. So let's go to our notes and let's write that down. And for finite sequence, let's put it in our own words. Let's say it's just a limited list of numbers. And I wrote an example right here, 2, 4, 6, 8, and that's it. I mean, it's just a list that's 4 numbers long. Yeah, there's a pattern right here. It's the even numbers, 2, 4, 6, 8, but it is limited. There's only 4 numbers in this list, in this sequence. Now, when we compare that to infinite sequences, well, that would be a list that continues on forever, and you know that with the symbols ... So again, here's an example of it. Same thing, 2, 4, 6, 8, but this ... that means that it continues forever. So, I mean, the next number would be what? 10, and then 12, and then 14, and then 16, and it continues forever. So far, I think it's pretty straightforward. What is a sequence? A sequence is just a list of numbers, right? What's a finite sequence? It's that list of numbers. It has a beginning and an end, right? It's a limited amount of numbers. An infinite sequence is just an infinite list of numbers that continues on forever. Okay, let's go back to our book and continue our notes. This is something very important right here. It says the first term of a sequence of a list of numbers is denoted as a sub 1, all right? The second term is denoted as a sub 2, and so on and so on. Okay, so don't get confused with that. All it's saying is that if you go to any list of numbers, the first number will be a sub 1. The second number will be a sub 2. That's just the notation. A sub 3, a sub 4. And there's only 4 terms on that finite sequence. But I hope we understand, like if I tell you, hey, look at a sub 3, which one am I talking about? I'm talking about 6. Down here, what would a sub 5 be? Okay, think about that. And down here, what would a sub 5 be? So if I tell you as like a homework problem, find a sub 5. Well, think about that. If this is a sub 1, a sub 2, a sub 3, a sub 4, what's a sub 5? It's going to equal 10. So a sub 5 equals 10. Boom. Easy peasy lemon squeezy. So a sub 1, a sub 2, don't get confused. That's just talking about which number you want to look at, right? A sub 4 is looking at 8. If I say find a sub 5, I'm telling you find the 5th number. If I say find a sub 17, I'm really saying find the 17th number on the list. All right, let's go back to our book. So sequences as functions, what's a function? It's like a machine, right? You plug in an input, you get out an output. And this is a key concept right here, sequences as functions. They want you to understand that your domain is going to be natural numbers, right? It says right here, sequence is a function in which the domain consists of natural numbers. So we need to remember what domain is. Domain are your inputs. So the numbers that you're going to be plugging into your function machine will be the natural numbers. And what are natural numbers? It's those numbers that you learn naturally as a child. Did you start counting with the number 0? No, you started counting with 1 and then 2 and then 3. So when we say that the domain, the inputs are natural numbers, we're talking about putting in the 1, the 2, the 3 into whatever our function is so we could get out our answers. And whatever those answers are, the first answer, that's really technically a sub 1. Remember, it's the notation for the first one on your list. A sub 2 is technically the second number on your list. So this all makes sense here. They give you an example of finite sequence. Right here's 5 numbers. Infinite sequence, 5 numbers, but it continues ... forever. Right here, they give you the domain 1, 2, 3, 4, 5. Yep, natural numbers. The range, you get 3, 6, 9, 12, 15. And if we wanted to, we could actually go deeper into this and say what function actually produces when you plug in a 1, you get out a 3. When you plug in a 2, you get out a 6. When you plug in a 3, you get out a 9. Well, we do see that we're multiplying the inputs by 3, right? 4 times 3 is 12. 5 times 3 is 15, right? So if we wanted to, we could say that this function right here is really y equals 3x. They're not even doing this on the example, all right? I'm going even further, above and beyond right here. So if they tell us, oh, find a sub 7, all right, a sub 7, what's that really saying? That notation is saying to find the 7th term on the list. Now there's only 1, 2, 3, 4, 5, but if it kept going, then you would find the 7th term. And yeah, one way of doing it is to keep going. 15, the next one would be 17, then the next one would be 19, and then the 7th one would be 21. Or another way of doing it is recognizing that the 7th number will be the input of 7 into your function if you already have your function. So you plug it in, and 3 times 7 is 21. So if you did go out to the a sub 7th term, a sub 1, a sub 2, a sub 3, a sub 4, 5, 6, 7, then you would have a 21 over here. A sub 7 does equal 21. So I went way ahead. I probably shouldn't have done that. I'm sorry. Anyway, I hope we understand that. If you don't, it's okay. We'll get to that in a couple of minutes again. So let's jump to our first huge definition here, arithmetic sequence. What is an arithmetic sequence? Okay, what's a sequence? It's a list of numbers. All right, we understand that. We know finite or infinite, but if they throw in this word right in front of it, arithmetic, and some people read this as arithmetic, I say arithmetic sequence. What does that mean? It's saying that each term is determined by adding a constant value to the previous term. This constant value is called the common difference. Okay, so let's go back to our notes and let's write down arithmetic sequence. Arithmetic sequence is a list of numbers that has a common difference. And usually they'll refer to that common difference as the variable d. Okay? So arithmetic sequence, it's a list of numbers that has a common difference. Now, let's really understand that the word common means that it has to appear everywhere. So let me give you an example. Let's say you had 11, 16, 21, 26. This would definitely be an arithmetic sequence. Now, why is it an arithmetic sequence? Well, how about this? Even before that, what's a sub 1? A sub 1 is 11. What's a sub 3? A sub 3 is 21. Okay, we understand the positioning and the notation. But this is an arithmetic sequence. Why? Because it's a list of numbers that has a common difference. So what do I mean by common difference? Take any number, like let's say 16, and subtract the previous one from it. Now, I know that all of us could see this and say, oh, 11 plus 5 is 16. 16 plus 5 is 21. 21 plus 5 is 26. I already know that you guys already know that the common difference is 5, okay? But trust me when I say this. Get used to picking any number and subtracting the previous number with it, all right? So go ahead and do 16, take away 11. That gives you 5, okay? Go ahead and do 26, take away 21, and that will give you 5. Go ahead and do 21, take away 16, and that'll give you 5. And that difference has to be in common all the way through, okay? So this is definitely an arithmetic sequence. Let me give you an example of something that's not an arithmetic sequence. Let's say we had 11, 16, 20, 25, 30, 35. That's not an arithmetic sequence. Why not? Well, is there a common difference? Now you might be saying, yeah, there is a 35 take away 30, that's a difference of 5. 30 take away 25 is a difference of 5. 16 take away 11 is a difference of 5. But right here, 20 take away 16, that's a difference of 4. I forgot the comma. So this is definitely not arithmetic. Why not? Because it doesn't have a common difference. Yeah, there's some difference. It's not common. It's not on every single pair of numbers. So that common difference has to exist in every single number, all right? Every single pair of numbers on your list. I hope this makes sense. So going back to the book here, we see that in an arithmetic sequence, each term is determined by adding a constant value to the previous term. The constant value is called the common difference. Consider the sequence 3, 6, 9, 12, 15. We'll see, how do you get from 3 to 6? It's plus 3. From 6 to 9, it's plus 3. From 9 to 12, it's plus 3. So there's a common difference of plus 3. Now, my suggestion, again, is not to think of how much you're adding each time. My suggestion is picking a number and subtracting. Difference means subtract. Subtract the number before it, okay? It'll become a lot clearer, like on this guy down here. It says, determine whether each sequence is arithmetic. Well, I would rather do -6 take away 5. -6 take away 5, that's a common difference of -11. -17 minus a -6, that's -17 plus 6, that's a common difference of -11. -28 minus -17, that's really -28 plus 17, that's really a common difference of -11. So there is a common difference between all these numbers. So this is definitely arithmetic. Over here, there is no common difference, right? If you went 12 minus a -4, that's 12 plus 4, that's 16. 28 take away 12, that's 16. 42 take away 28, that's 14, it's not 16. So this is definitely not arithmetic because there's no common difference. So let's move on to the next page. Let's go to example 2 on this next page. They say, consider the arithmetic sequence. They're telling you it's arithmetic. They're telling you there's a common difference. What is that common difference? 14 take away 18, that's really a -4. 10 take away 14, that's really a -4. So as we could see, the common difference is -4. So they want you to find the next 4 terms of the sequence. Again, let's begin by stating, now they show all the work here, but if I were doing this on my piece of paper, I would begin by looking at 14 take away 18, that is -4. And again, verify that it's common. 10 take away 14, that's also a -4. So my difference, my common difference is -4. Now what does that really mean? That 18 take away 4, that's 14, take away 4, that's 10. And they want you to find the next 4 terms, okay? Now, if you really want to get fancy about this, what I would do is write down, well, if this is a sub 1, a sub 2, a sub 3, I would write down a sub 4, a sub 5, a sub 6, a sub 7. That's the correct notation for the next 4 terms, okay? So what would the next term be if your a sub 3 is 10? The next one would be 10 minus 4, which is 6. So the a sub 4 term, that's 6. And then 6 take away 4, that's 2. And then 2 take away 4, that's -2. And that take away 4 is -6. So these are the next 4 terms of this arithmetic sequence. And we even took it a step further and gave the appropriate notation for each of those terms. A sub 4 is 6, a sub 5 is 12, a sub 6 is -2, a sub 7 is -6. And right here, they just want to show you that if you graphed it, it does give you a linear, they all line up, right? Let's move on to the next page. So I hope we understand what an arithmetic sequence is. Arithmetic sequence, going back to our notes here, has a common difference. Again, this is what I want you to memorize right now. Arithmetic sequence has a common difference. Arithmetic sequence has a common difference, all right? So we're going to be able to identify arithmetic sequences just by seeing if it has a common difference, compared to geometric sequences, which is another type of sequence, another type of list. And in geometric sequences, each term is determined by multiplying a non-zero constant by the previous term. This constant value is called the common ratio. Okay, so that's all sounding pretty confusing. Let's go to our notes and let's write down geometric sequence has a common ratio. I'm sorry about that. A geometric sequence is a list of numbers that has a common ratio r. So just remember that. Geometric sequence has a common ratio r. Compared to arithmetic sequence, did I just say sequence? I did. Arithmetic sequence, sorry about that. Compared to an arithmetic sequence, which has a common difference, d. Now you're probably thinking, well, okay, I know what a common difference is, but what's a common ratio? Well, what is a ratio? What does the word ratio mean? Remember, a rational number? A rational number has the word ratio in it, and a ratio is really a fraction or a decimal. So a geometric sequence is a list of numbers that has a common ratio, a common fraction. Now let me show you how to get that fraction. So just like before, when you had a list of numbers and you wanted to check for a common difference, like is there a common difference right here? Absolutely not. If you go 16, take away 4, that's 12. So there's a difference of 12 between the numbers 4 and 16. But if you go 4, take away 1, that's a difference of 3. So that's definitely not a common difference. So right here, do we have a common ratio? And the answer is yes. But let me show you how to get that common ratio R. Similar to the way I told you to find a common difference where you take 16, take away 4. Right here, a common ratio, which is a fraction, I want you to take the 16 and put it over the previous number 4. So what is 16 over 4? That's really 16 divided by 4, which means that the answer is 4. Now, is it common? Well, if you take 4 divided by 1, that's also 4. If you take 1 divided by 1/4, and if we think about that, 1 divided by 1/4 is really 1 times the reciprocal, 4 over 1, and 1 times 4 over 1 is really just 1 times 4, which again, the answer is 4. And if you were to take 1/4 divided by 1/16, it's really 1/4 times the reciprocal, which is 16 over 1, which also equals 4. So the common ratio is 4, okay? That's a geometric sequence, a list of numbers that has a common ratio. So again, I want you to get used to practicing finding the common difference or the common ratio by looking at a number and then looking at the previous number right before it, okay? So for common difference, try 16 take away 4, oh, that's 12. 4 take away 1, hey, that's not 12. So this is not a common difference. Try common ratio, 16 divided by 4, yeah, that's 4. 4 divided by 1, yeah, that's 4. 1 divided by 1/4, yeah, that's 4. 1/4 divided by 1/16, yeah, that's 4, if you do the math. So now that we know that a arithmetic sequence has a common difference and a geometric sequence has a common ratio R, now we'll be able to distinguish which one is which. So right here they're telling us, determine whether the sequence is geometric, all right? So is this geometric? If it is geometric, that means that if I take, well, let me just look at the definition over here. Geometric sequence has a common ratio R. If it has a common ratio, then it will be geometric. Pick a number, 6. 6 divided by -2. What's that? 6 divided by -2, that is -3. How about 54 divided by -18? If you did that, they show the work here, it is -3. If I do -18 divided by 6, they show the work here, it is -3. So there is a common ratio. That ratio is -3, -3, -3. So the ratio, the common ratio is -3, okay? So this is geometric. And why is it geometric? Because there is a common ratio that exists between all the numbers. Look at this next one. If you go 16 divided by 8, that's 2. If you go 24 divided by 16, that's not 2, that's 1.5. If you go 32 divided by, so you don't even have to do the last one. If they're not the same common ratio, then it's definitely not geometric, all right? Now, if it had a common difference, then it would be arithmetic, okay? It's that simple. And that's all we're really doing today. We are practicing. Now, let's say, oh, you're freaking out because there's decimals. Go ahead and type it in your calculator, right? 2 divided by -8, that's -1/4 or -0.25. Go ahead and do 0.5 divided by 2. And if you get -0.25, and if you do this one divided by this one and it's -0.25, then you know that the common ratio is -0.25 or -1/4. It is geometric. If they're not all the same, then it's not geometric. Over here, it's a little easier to see. Is this geometric? Well, 3 divided by 1 is 3. 7 divided by 3 is not 3. Okay, and neither is 15 divided by 7. So there's definitely not a common ratio here. So this is not geometric. As a matter of fact, I could even go further and say it's not arithmetic either, because 15 take away 7 is 8. 7 take away 3 is not 8. So it's not arithmetic either. Okay. And they also explain right here on example 5 that if you consider a geometric sequence as a function, like where you start off with the output 32, and then you plug in a 2 and you get the output 8, and then you plug in a 3 and you get the output whatever that is, probably 2, yeah, 2 or 1, 2 I think. It's going to produce this graph, and a geometric sequence is not a line like an arithmetic was. Right here, a geometric sequence, it's kind of like an exponential decay function. It started off as 32, it decays. It decays by what? By that common ratio. And what was that common ratio? That common ratio is 1/4, right? If you take 2 divided by 8, it's 1/4. 8 divided by 32, it's 1/4. So it's decaying by 1/4. So it's actually a decay function as opposed to a linear function, which was arithmetic. So arithmetic is linear. Geometric, it's actually an exponential growth or decay function. Right here, it's a decay function. Let's move on. I apologize for this huge video, but we get here to the meat and potatoes of what your goal for today is. And what's the goal? To be able to identify whether if this list right here is arithmetic, geometric, or maybe it's neither. Maybe it's just a list of numbers that does not have a common difference and it does not have a common ratio. Maybe it doesn't have anything. It's just a list of numbers. So right here, 16, 24, 36, 54, check for a common difference. If you go 54, take away 36, you get 18. They show you the work right there. 36, take away 24, that is not 18, it's 12. So you can stop right there. This is definitely not arithmetic. Why? Because there is no common difference. So then you move on. Okay, let's try geometric. Well, if I go 54 divided by 36, that will reduce down to 3/2. If I go 36 divided by 24, it does reduce down to 3/2. 24 divided by 16, 24 over 16, it does reduce down to 3/2. There is a common ratio, which means that this list right here is geometric. And if they say explain your reasoning, it's geometric because it has a common ratio, common R, of 3/2. Okay? Let's move on. 1, 4, 9, 16. Is there a common difference? Well, 4 take away 1 is 3. 9 take away 4 is not 3. So it does not have a common difference. Let's try common ratio. If you go 16 divided by 9 on a calculator, it'll give you 1.7777. But if you try 9 divided by 4 on a calculator, it'll give you 2.25. So it did not have a common difference. It did not have a common ratio. This is where you would say neither. That's just a list of numbers. Who knows what kind of relationship or what kind of growth is going on right there. But it's definitely not arithmetic and it's not geometric. It's neither. And for your explanation, why not? Why is it neither? Because it has no common difference and it has no common ratio. That's exactly what they explained down there. Might as well do C right here. 17 take away 23, that's -6. 5 take away 11, that's -6. 11 take away 17, that's -6. There is a common difference. What does that mean? That this is arithmetic. Okay, again, arithmetic has a common difference. Geometric has a common ratio. And whether you want to find the common difference or the ratio is where you pick a number and use the previous number from it, okay? So 11 take away 17, 5 take away 11, 23, or 17 take away 23. They all give you -6 as the common difference, so this is arithmetic. Arithmetic, why? Because it's a common difference. And the common difference is -6. So let's move on to today's assignment. So we're going to go work straight from the book here, page 663, and your assignment will be page 663, numbers 1 through 30 odd. It sounds like a lot, but it's pretty easy. And, you know, you need to practice this in order for it to stick to your memory. So when we look at number 1, they want you to determine whether it's arithmetic. Just simple. Is it arithmetic? Yes or no? All right. Now remember, arithmetic has a common difference. You need to be able to find that common difference. It has to exist in every single one. And the way I told you to do it is to pick a number, subtract the number right before it. Now, some of us are seeing 8 and 2 and they're thinking 6. But you see, do what I tell you. Pick the number, subtract the previous one from it. So let's write that down. Negative 2 minus 8, that is negative 10. Let's do this next one. How about negative 12 minus a negative 2? Negative 12 minus a negative 2. Does that give you negative 10? Yes, it does, because the minus minus changes the plus plus. And how about the last one that we're checking right here? How about negative 22 take away a negative 12? Let's write that down. Negative 22 take away a negative 12. And that becomes a plus plus, and that also gives us a negative 10. So there's definitely a common difference on number 1. The common difference is negative 10, which means yes, it's arithmetic. Okay, so you're obviously going to have to write this down in your notebook, right? There's not much space right here, obviously. So you guys could do number 3, check if there's a common difference. It's pretty clear that there's not. Now the next part, it says find, the next 4 terms of each arithmetic sequence. So they're telling you it's arithmetic. They're telling you that there's a common difference, okay? And they want you to find the next 4 terms. And I would like you to get extra fancy and use the notation for the 4th term, the 5th term, the 6th term, the 7th term, all right? So number 5, a sub 1, that's really 6. The first number on your arithmetic sequence here is 6. A sub 2 is 18. A sub 3 is 30, okay? So what's a sub 4, what's a sub 5, a sub 6, and a sub 7? Well, in order to determine that, we first need to find that common difference that makes this arithmetic. So if I take 18 and I subtract the one right before it, 18 take away 6 is 12, okay? So the common difference is 12. In other words, from 6 to 18, the difference is 12. I add 12 to it. 6 plus 12 is 18. 18 plus 12 is 30. 30 plus 12 will give me the 4th number on my list. 30 plus 12 is 42. For the next one, let's add 12 again. That'll be 54. And for the next one, again, add 12. That'll be 66. And for the 7th term, add 12 again. That'll be 78. So in the answer sheet, they're probably not going to write it the way I did right here. A sub 4 is 42. A sub 5 is 54. They'll probably just write the answer as a continuation right here. 42, comma, 54, comma, 66, comma, 78. But I'm telling you, this right here, you're ahead of the game if you're already understanding the notation. So let's use the notation. A sub 4 is 42, a sub 5 is 54. So I did number 3. I did number 1, you guys do number 3. I did number 5, you guys do number 7. I'll do number 9 since we didn't go over any word problem examples. Let's think about this. It says Kelly's saving her money to buy a car. She has $250. She plans to save $75 per week from her job as a waitress. How much will Kelly save after 8 weeks? All right, so let's first start by converting this word problem into an actual list of numbers. So what is the first output, the first number on your list of this geometric sequence here? Arithmetic sequence. She starts with $250, okay? And then after 1 week passes, what happens? Well, she has $75 more that she's going to save into this account. So she's going to have $325, and then she has another 75. That'll be 400, and we know it, it keeps going. She could save forever, but they want to specifically know how much she's going to have saved after 8 weeks. So they have a sub 1, they have a sub 2, a sub 3. They really want a sub 8. They want the 8th week, right? And to find that, you could just easily, I'm not going to show my work here, I don't have any space, but get a calculator and just say, okay, a sub 4 will be 475 by adding 75, and then add 75 again, that'll be a sub 5, add 75 again, a sub 6, till you get to a sub 8, which is the 8th number on this list, okay? Then you could, you know what, let's just skip number 9. But we understand how to do it, right? Let's stick to the basic practice here. Number 10, determine whether each sequence is geometric, okay? Write yes or no. So arithmetic had a common difference. Geometric has a common ratio R, okay? And again, how do you find that common ratio R? you take a number and divide it by the previous number. So you put 108 over 36. And then you take another number, the 36, and put it over 12. 36 over 12. And then you take another number, the 12, and put it over 4. So you always pick a number and divide it by the previous number. Okay, so 12 over 4. Now, again, the question is this sequence geometric? Well, do they have a common ratio? 12 divided by 4 is 3. But when you go to 36 divided by 12, that is 3 also. Okay. And how about 108 divided by 36? That's also 3. Wow, it wasn't that clear, but if you actually divide 108 by 3, it will give you, 108 divided by 36, it will give you 3. 36 divided by 12, it is 3. So it is a common ratio. So 11, yes, it's geometric. Why is it geometric? Because it has a common ratio of 3. So 11 has a common ratio of 3. So yes, it's geometric. Okay, so you guys could do that with number 13. And same deal here, find the next 3 terms of the geometric sequence, then graph the sequence. All right, so they're telling you it's geometric, which means that there's a common ratio, and you want to find the next 3 terms. So I'll go for the one that has positive and negatives. What's the common ratio right here? Well, you have -3 divided by 9. That's a common ratio of -1/3. They're telling you that this is geometric. You could test it if you want. Continue and go 1 divided by -3. That's a common ratio of -1/3. So on number 17, we could state that the common ratio is -1/3. And that's exactly how you get from 9 to the -3. How do you get from 9 to -3? 9 times that common ratio, -1/3, will get you to the -3. -3 times -1/3, that'll get you to a +1. +1 times -1/3, that'll get you to a -1/3. So if you want the next 3 terms, and again, let's be fancy about it, a sub 1, a sub 2, a sub 3, a sub 4, let's write down a sub 5, a sub 6, and they only want 3 terms, a sub 7, okay? Oops, I wrote that 6 kind of big. That should be smaller and down here. But anyway, what would -1/3 times the common ratio of -1/3 give us for our 5th term? That'll give us a +1/9. So the a sub 5 term, that'd be +1/9. And then +1/9 times -1/3, that'll give you your next answer, which is -1/27. And -1/27 times -1/3, again, that'll be +1/81. So we could safely say that this is geometric. Why is it geometric? Because it has a common ratio of -1/3, and the next 3 terms, a sub 5 will be +1/9, a sub 6 will be -1/27, a sub 7 will be 1/81. Okay, and you guys could do the same for number 15. And then right here we have determine whether each sequence is arithmetic, geometric, or neither. All you have to do is number 19, since we're doing the odd ones. I'm not going to do that one for you since it's the only one that you have to do. If I went 7 over 1, that'll be 7. If I go 1 over 5, that's not 7. So it's definitely not geometric where there's a common ratio. Maybe there's a common difference. 1 take away 5 is 4. 7 take away 1 is 6. Nope, no common difference. So this is definitely neither. It's just a list of numbers. It's not arithmetic. It's not geometric. Okay. So I hope you guys could figure it out. Even number 20. 16 take away 12, that's 4. 20 take away 16, that's 4. 24 take away 20, that's 4. There's a common difference right here, which means that this is arithmetic, not geometric. Okay. Again, main point for today, arithmetic has a common difference, geometric has a common ratio. So the second half of this worksheet is pretty much a repetition of what we already did. Again, determine whether it's arithmetic, write yes or no. Arithmetic has a common difference. And then find the next 4 terms of that arithmetic, and we stop on number 30. You know what, actually, after thinking about it, why would we do the same thing over again? So let's scratch that out. Let's make this 1 through 19 odd. Yeah, that'll be better. 1 through 19 odd, and I already did half of it for you, so let's switch this. There you go, 1 through 19 odd. I already did half of them for you. I'm sorry about the long video. Do the homework. I might ask for you to send it to me through Remind on Friday. One more thing before I let you go. Remember this. Arithmetic sequences have a common difference D, and a geometric sequence has a common ratio r. And whenever you're looking at your list, remember these are just numbers, first number, second number, third, fourth, and you want to find whether it's a common difference or common ratio, pick a number and then either subtract it by the previous number or pick a number and divide it by the previous number, right? If you're checking for difference, a sub 4 take away a sub 3, a sub 3 take away a sub 2, a sub 2 take away a sub 1. Or if you're trying to check if it's a geometric sequence, a sub 4 divided by a sub 3, a sub 3 divided by a sub 2. That will give you either the common difference or the common ratio.